So today we want to talk about actually writing the equations of sine and cosine. If you are given the graph, or if you're given the properties, the attributes of the graph, how do we take that information and then write the equation, just going in the other direction? So it is helpful to remember what that generic form of the equation was. We have y equals a times sine or cosine, whichever one you're dealing with, times b and x minus h plus k. So we need all of that information in order to write the equation for a graph. We need to know where is its midline. We need to know what is its period, because if we know its period, we can find its angular speed. We need to know what its amplitude is. And we need to know if it shifted off of the y-axis to start. So, if I can find all of that information, well, if I have the graph, all that information is there. I just have to look for it. Sometimes it might be a problem where they tell you what the amplitude is, or if it's a word problem and they tell you what the radius of the circle is that you're trying to model and stuff like that. They give you this information. So we just need to find this information. So looking at this graph that we have up here, I'm going to try and isolate one cycle. So I notice right away on the y-axis, it appears that on the y-axis, it is the middle of a wave. It's bouncing between 3 and 1, so the middle would be 2. So that's given me two pieces of information there. I now know that the midline is at 2, so it's exactly in the middle, bouncing between 1 and 3, so the midline is at 2. I also know that it starts on the midline. It's starting in the middle, which means that it is going to be sine. If it's starting in the middle, it's going to be sine. It also tells me that it didn't shift any to the left or the right. It is actually on the y-axis. If you're middle of the wave or if you're top of the wave, neither one is on the y-axis, that's when you realize you've had a phase shift. But if the middle of the graph or if the maximum of the graph is on the y-axis, then that just helps you identify whether it's sine or cosine. It also lets me see that the amplitude from the midline to the top and from the midline to the bottom is 1. So I know that my amplitude is 1. I also notice that it's going up right from the get-go, so that tells me that it's positive 1. It didn't get flipped over. I don't have a phase shift. Well, now I just need to know what is my period so I can figure out what this angular speed is. So up, back to the middle, down, back to the middle. That was one complete graph. And it looks like one complete graph was pi over 2. So we got through one full cycle in just pi over 2 seconds. And we know the angular speed is radians per second. And so what we need to do is to figure out what was the original angular speed. We're just going to take that 2 pi, because we know one full cycle all the way around is 2 pi radians, and we're doing it in pi over 2 seconds. And so now we just need to do a little cleanup here. If I do 2 pi divided by pi over 2, let's see, 2 pi over 1, so we keep change flip, so this will be 2 over pi. So the pi's will cancel out, and that means that our angular speed is 4 radians per second. So that tells me that b is going to be 4. So now I can actually write the equation that goes along with this graph. So it's going to be y equals 1 sine, and the 4 per second, and it's just x because I didn't shift it to the left or right any, but we did bump it up to 2. So it's y equals sine of 4x plus 2. For our next example, let's look at this graph. So things that I notice that it is starting here at the bottom of a wave. Well, sine starts at the middle of the wave, and cosine starts at the top of the wave. So there's two ways you can think about this, and this is something that frustrates a lot of students. Oftentimes with waves, you can have multiple equations that actually model the exact same wave. And that's an interesting concept. And it's because the sine and the cosine wave are the exact same shape. Their only differences are where they start. So depending on how you shift the graph, you can shift them to be right on top of each other. But anytime that I notice that the start is at the top or the bottom, if it's at the top or the bottom, I consider that to be cosine, because the top of the wave is where cosine normally starts. So if it's at the bottom of the wave, that just means that it's going to be a negative cosine. It started at the bottom instead of the top. So that gives me, that negative piece. So that's how I usually think about cosine. If it starts at the bottom or the top, it's cosine. If it starts in the middle, then it's sine. And if it doesn't start in any of those three places, then it has been shifted left to right. And so we have to take that into consideration. So I know this one's going to be a negative cosine. I also notice it's going between 0 and 4. So that would put the halfway here at 2. So my midline is at 2. So I know that it's going to have a plus 2 out here on this part of the equation. It did start at that peak of the graph though, so it's not shifting left or right any, so it's just x. I don't have anything added on the inside here. I need to look for that amplitude. Okay, so my amplitude is 2 because my midline's at 2. It goes up to 4 and down to 0. So I have an amplitude of 2. It is negative though because we started at the bottom instead of the top. And now to look for one full cycle. So we go up all the way to the top and we come all the way back down. And it looks like our period is 120. Now, again, we kind of have to use the context clues to let us know whether we're in radians or degrees. Also, read directions carefully. The directions should sometimes tell you whether it's radians or degrees. But by the way that this graph is counting, I'm going with this is in degrees, not radians. I lack pi. Pi is usually the dead giveaway that you're dealing with radians. So I am dealing with degrees, and so my period is 120. So if it took 120 seconds to go the full 360 degrees around the circle, 360 divided by 120 is 3. So that means we were going 3 degrees per second. So my angular speed is 3. And that is all the information that I need to write the equation for that graph.